I will today. That's actually chapter 10.2. Yeah, we probably started it. So I'll finish 10.2 and we'll go into 10.3. So, just as a recap, guys, let's double check what functions. Oh, I also wanted to talk to you guys about horizontal points of inflection. They're in the Sketchy Curves handout, but I didn't really mention them to you guys. So, that's not quite right. Okay, so we're going to look at, yay, they all showed. Good morning.
You were wrong.
I was wrong, and I'm going to eat my words. Actually, no, there's still a few people missing, but most of you showed up. I'm so happy. That makes me happy. Thank you. Because they know that it's coming on Tuesday. They'll be like, no, Tuesday's a bad day to miss, you guys. Hi, Memo. Are you going to hold that up the entire time? Would you like me to bring you a little like Gorilla Grip so you can like attach it to something and then do your thing? Not your head, because then it'll be all over the place. Every time Emily says something, you'll be like, and then we'll get the close-up of Emily, which is kind of awesome, but yeah. So I'll bring you a Gorilla Grip, and you have a little screw-in feature on the bottom, right? Okay, groovy. Yeah, I'll bring you one. You can attach it to something.
Is Tuesday 11.1?
Yeah, Tuesday's 11.1. Bad day to miss, so try to be here, guys. Bad day to miss. Yeah, it's logs.
I love logs.
We like logs.
That was a joke.
No, we like logs. After Monday, you guys are going to like logs because the derivative is really easy for a logarithm. It's really, not Monday, Tuesday. Derivatives are really easy with logarithms. There's rules for them, and they're all, oh, yay, yeah. There's another thing I want to tell you guys about. Sorry, I'm sort of in, oh, I don't have one, never mind. I'm gonna give you guys a tool on Tuesday. You're gonna use it for the rest of the semester. I think I've touched on it before. It's called the Tattoo. It contains your entire semester on one page, and it includes all the logarithm stuff. So it'll be like measly the stuff that we've covered before next Tuesday, but after next Tuesday, we'll have most of the board because that page is primarily concerned with all the logarithm shortcuts. We like shortcuts, right? Yeah. Okay, groovy. All right. So today, back to this topic. I'm going to do slope and concavity profiles for these. So I'm going to start with this guy right here. Slope and concavity profiles. To remind you guys what true max and true min look like. Okay, so first of all, what kind of slope do we have in this region?
Negative.
Negative until that spot, right? Mm-hmm. And then it becomes 0. So we have a 0 slope there and a negative slope before it, right? What about in this region?
Positive.
It's growing until this point, at which point it tops out. So we have a positive slope in this entire region. And then after that x value, what happens? Zoom type.
Goes down.
It's negative. Okay, so that's our slope profile for this function. If we were to sort of draw this, we could kind of tell where the maxima and minima are. Negative slope, 0 slope, positive slope, 0 slope, negative slope. So that's exactly what's happening here. So we can kind of tell where the maxima and minima are, but we need to verify this. So let's talk about concavity. So concave up is a happy face. Concave down is a sad face. Where does it change from happy to sad? Where? Let's do this again.
0.
Somewhere in here, right? So this spot right here is going to be where concavity is 0. And then we had a happy face on this side and a sad face on this side. I know it seems really unscientific to say that, but concavity is just that simple. It's whether it looks like a happy face or a sad face. And it can be a partial happy face or sad face. For example, is that happy or sad?
She doesn't know.
It's a stroke victim. I'm kidding.
Oh, God.
God, you guys. And away. No, seriously, is that a happy or a sad face? Look at the shape of it. It's a sad face. Okay, what about this? Happy or sad? Still sad. What about this? Happy face. I know I'm terrible. I'm going to hell. I'm sorry. Is that a happy or a sad face?
Happy.
So we don't need a lot of information to tell us whether it's concave up or concave down. Where do we go to get slopes, you guys? Plug an x into a function, what do we get out?
Y.
A y. If we plug an x into a derivative, what do we get out?
Slope.
Slope. I'm gonna write this wrong, I know it. And if I plug an x into a second derivative, what do I get out?
Concavity.
That's where you get concavity. Okay? So how do I verify concavities on either side of these functions? Or on either side of these x values? I would pick any test value in this region and plug it into the second derivative. And the sign of the answer tells me whether it's concave up or concave down. That's all there is to it. Okay? We'll do some math examples, but for now, let's move on to this next guy. By the way, what does that maximum look like? What's the profile for it? It has what kind of slope? 0. What kind of concavity does it have? Negative. So true maxima have these qualities. The first derivative equals 0, and the second derivative is negative. You guys with me? And it's kind of in the shape of the picture here. This kind of looks like it's topping out. It looks like it has a maximum, a maximum built in. What about down here? What does a true minima look like?
That's 0.
The slope is 0 still,
Yeah?
and it's positive.
And what's positive?
Second derivative.
Yeah. Yeah, second derivative is that happy face. So true minima have a 0 slope and a positive concavity. True maxima have a 0 slope and a negative concavity. Everyone cool with that? How do we find false maxima and minima? Well, before we took derivatives and set it equal to 0 and solved for x. But here's the problem with that. Once we get into more sophisticated functions, in this function, there's two places where the slope equals 0. Here and here. Right? So which one's the maximum? If you don't have the chart in front of you, if you don't have the graph, how do you know which one's the maximum?
Whichever one's second derivative is bigger,
Whichever second derivative is bigger?
more positive,
Yeah,
more negative.
that's a good thought, right? But you're thinking in terms of y values, right? You want to know which y value is higher. So you could go and plug these x values into the function to get out the corresponding y's, and whichever one is higher is the true max. You with me? So you can use the original function to do this, but you can also use the second derivative. Let me show you what I mean. And the second derivative sometimes is prettier than the first derivative, and sometimes it's a lot prettier than the original function. So let's look at this piece by piece. Concave up or concave down?
Down.
Is that a happy or a sad face? Yeah, that's right. That's a sad face. Until what point? Here. Oh. Do you guys know a point can be both 0 slope and 0 concavity? Because we're changing from concave down to concave up. Until what point? That's a happy face until, I don't know, somewhere around there. Right? So at that point, we had a happy face there and then sad face for the rest of it. You guys with me? So I can draw this just based on that profile. Let me show you what I mean. My first region, and I'm gonna kind of cut these. It's gonna get really noisy with the color. You guys wanna take a picture of this before I trash it? Okay. Because I know it's coming. It's gonna get bad.
Okay.
So notice, your first derivative gave you these 2 points, and you can use the second derivative to verify whether it's a true max or not. The second derivative gives you a zero concavity here. That's not a maximum. This one gives you a negative concavity. That's a maximum. You guys with me? Okay, you got your photos? Here we go. So I'm gonna slice this into regions using all of my critical values, which is what these points are, where slope and concavity equal 0. And I'm gonna draw it based on those things, based on those pieces of information. Oh, by the way, this was positive slope, negative slope, so that matters. Okay. So my first region has a positive slope and a negative concavity. Just like that. Okay? My second region has positive slope, positive concavity. Oh, and there was a change in concavity and slope. So slope flattened out for a second. And then we have positive slope, positive concavity. So far, so good. In the next region, I have positive slope, negative concavity. Chunk, chunk, chunk. And then I top out on slope, or I have a 0 slope. So I'm gonna mark that. And then after that, I have negative slope, negative concavity. Does that approximately look like what I drew? Okay, so you can use these very basic profiles to approximate the shape of this chart or graph. You guys with me? What's the hardest part? What's the hardest part for you?
For me?
Yeah. It's tedious, isn't it? Yeah. Yeah. So how many of you are gonna get lost with what's what? The derivatives, the second derivative, first derivative? How about the test values, right? Because if we shove anything in this region into our slope, we should get a negative answer out. And if we shove anything in this region into our second derivative, we should get a negative answer out. So that's kind of what we're talking about here. Test values between our critical values allow us to create some kind of slope and concavity profile. So far, so good, guys? All right. This is called a horizontal point of inflection. Horizontal point of inflection. And it's horizontal because the slope has flattened out for a piece there. Just for a piece, not for long. I've exaggerated it there. It probably would look more like this in the real world. Okay? What's the profile of the horizontal point of inflection? How much slope does it have?
Flat slope 0.
Yeah, slope is 0, so that's f prime. And then f double prime gives you what?
0 again?
Yeah, so concavity is 0 as well. Is everyone cool with that? So when you get a slope and a concavity of 0, that's an HPI, right off. So far, so good? I'm gonna erase this. All.
Just 1 second.
Ah! All right, I'll drink coffee.
The new stuff.
Yeah, it's fine. We've got lots of time today. Take your time, Maria.
Thank you.
Okay. God, I love this stuff. It's so much fun. No, it is. It is, because once you see the patterns in the math, it becomes a lot more fun. You can't see the patterns. This is why I'm such a visual learner. I don't know about you guys, but I like seeing the pretty pictures because it drives home the math to me. I like pretty pictures. All right. talk about the point of diminishing returns. Let's say you're doing a productivity problem. And productivity is almost always time on the x-axis instead of production. And then to throw a curve at you, production goes on the y-axis. So that's misspelled as well. Let me make that a little better. T-I-O, that's better. It ain't pretty, but it's better. Good morning.
Good morning.
Yeah, no, don't worry about it. So, where was I? Oh yeah, so time is on the x-axis with productivity functions, and production is usually on the y-axis. So what's happening here is as time goes on, production increases. It almost always takes some form of this curve. Right here. Take note, guys, this will be on your final. Yeah, Emily's like, in color. On final. So let's talk about what this means. Let's say the time span is 1 day in the life of a worker in your job or your business, your company. They walk in. How much have they produced? Nada. Because when time equals 0, they've done nothing. This is like 8 a.m. when they arrive, or 8:30 if they're late. 9 if they're permissive in their arrival time policies. But whatever. Wherever they arrive, they've done nothing at that moment. And then they get their coffee, and they get in their groove, and they're producing, right? As time goes on, production's going up. But the steepest slope is where?
It's in the middle of the line.
Yeah, it's in the middle, right? It's right here. What's special about that spot, you guys? It's the middle of the day, right? They've hit their groove. Good, who said that? Devarius. Devarius? Sorry, Devarius. Let me get it right. I will. I see you later, right? Yes. Okay, groovy. So we hit the middle of the day, as Devarius said, and then what happens? We break for lunch. And we come back. So time is on hold at this point, right? Because this is your productive day. So time's on hold. And then we resume. And what happens? You're still in your groove, but then what?
Coffee wears off.
Yeah, your coffee wears off. You start to wind down your day, right? Production's still going up, but is it nearly as effective? No.
So you shorten the days.
No, that's not why, because you're losing that extra little production. Here's the trick here. So mathematically, what's special about this spot, guys?
Maximum return.
Right, it's the steepest slope, so maximum rate of return. What? Yes, we go from concave up to concave down. So what kind of concavity is right here? 0. This is where the second derivative equals 0. This is the point of diminishing returns. And we have a lot of ways to express this. Colloquially, I totally botched this yesterday with my other class, but colloquially, the point of diminishing returns is throwing bad money after good, or getting less bang for your buck, okay? So at this point, your rate of return starts to slow down. How many of you want to make $1 million? How many of you won't be satisfied with $1 million? I wouldn't either. I'd be like, yeah, I want more. That's why I'm making $52,000 a year as your instructor. Nah, it's cool. I really love my job, you guys. So,
It takes 20 years.
what?
It'll only take you 20 years if you don't get it.
Right! If I don't eat.
Or live anywhere.
And I live under a bush. That. Yeah, and I don't get sick, and I don't need a ride to work, and I never buy clothes, so I'm naked under a bush, starving. That's how I make $1 million. Good times. All
Very
right.
dirty.
It's Darius. No, this would just be a working day, for example. But this could be a working year, or this could be an entire group. So the way we set this up, it depends on the nature of the function, but the function itself will look the same. The point of diminishing returns is where that second derivative equals 0. And here's the thing, efficiency experts, that's why I asked about making $1 million. Efficiency experts come into corporations, they park themselves. How many of you guys have heard of people like this? Yeah, they park themselves, they analyze your processes, they analyze your employees, they want to check out who's doing what and why, and they find the places that aren't working so well and the places that are. Where are you working best? Right there. So what if you could expand that slope longer? What would your overall production do? Go up. So this is an oversimplified version of what efficiency experts do, but they make a ton of money doing it. I basically believe to myself, that's fun. Yeah, they make a lot of money doing it. Of course, part of the efficiency process is firing a bunch of people, so it also hurts morale. So there's a downside to it too, but if money is all you care about, go do that, because that's a great way to make a living. If you care about people, don't do that. How do you guys feel? How many of you are going into advertising? Anybody? Advertising? Yeah, okay. This works too. In advertising, you've got some kind of advertising campaign that you've released, and over time, people start to hear about it, there's buzz, but then you reach saturation point, right? People no longer need to see your ad to know that that thing is out there, right? You no longer have to spend the money. So at some point, you're throwing gesundheit, bad money after good. You're getting less bang for your buck after this point. So what would you do if you were an advertising exec? What would you change after this point? Yeah, start pushing a new product or a new ad or a new ad campaign so that you're not giving people the same thing over and over and over again, because you're eventually going to hit saturation and your overall sales. In this case, this isn't productivity, this is time and sales. Ugh, I'll just do it in this color here. Time and sales. So this would be an ad campaign in dollars. But it's the same look, guys. It's the exact same thing. Okay? So far, so groovy. This is gonna be on your final. You're gonna need to know how to do this. But it isn't hard. How do you find the point of diminishing returns, guys? The second derivative, set it equal to 0, solve for x. Boy, that sounds real familiar, doesn't it? You guys are gonna figure out as time goes on in this class that you're doing the same thing, unless you've already figured it out, in which case go you. You're doing the same thing over and over and over and over and over and over and over again with different math, right? So far, so good? Saeed, you got it? Okay. Now let's talk about optimization. Oh, what the hell, let's do a point of diminishing returns problem. I did it for the other class, why not? You guys are gonna hate this problem. That's why I'm doing it on the board. Give yourself a fresh piece of paper for this one. Ads and sales, diminishing returns. Okay. So I'm giving you a sales function that's based on time, and that's 3 over t plus 3 minus 18 over t plus 3 quantity squared plus 1. Let me read you the statement of the problem. Suppose a company's daily sales volume attributed to an ad campaign is given by the following. Find how long it will be before the rate of change of sales volume is maximized, that is, find the point of diminishing returns. So rate of change of sales volume is maximized. They're saying the slope, rate of change, is maximized, is steepest. So they're looking for this point, right? That's what it means. So far, so good? Okay. So, is it pretty? Pretty ugly. Can I make it pretty? Yeah, just bring everything up top. So I'm gonna go 3 times the quantity t plus 3 to the negative 1 minus 18 times t plus 3 to the negative 2 plus 1. I have not taken a derivative yet. It is important to label the left-hand side of your problems, guys. We're gonna get to the point where we're working, actually we did it in the test, where we're working with a lot of different functions, and we have to know what's what and where to shove what, when. Groovy? So labeling is really useful. What's the first derivative gonna be? So let's see, negative 3 junk to the negative 2, so that's d out. What's the derivative of the inside of that?
T.
T?
1.
1. Awesome. And then the next one is positive 36 junk to the negative 3. And then the 1, you just kill it, killer. Well, not this one. And then the 1 on the end you kill. Okay. So I'm going to clean this up just a little bit. Negative 3 times 1 is
Still asleep, the coffee hasn't kicked.
I know that feeling. I am with you all the way there, Saeed. Okay. So all I did was I distributed my 1. So dn here is always going to be 1. So when I take the second derivative, I'm going to skip dn. You guys cool with that? When I do d out dn on these functions? Okay.
I'm sorry, can you repeat that?
Yeah, so dn on each of these terms is gonna be 1. So just like here, this is d out, this is dn. So I'm just gonna skip the dn for the next step because it's crowded. Second derivative. Don't overthink it. What's the derivative of that, guys? Oh, wait, yes.
Where did you get the t plus 1?
Where did I get the t plus 1? Oh, I don't know. What's your name again?
Anthony.
Anthony. Thank you. Anthony's on my list. Good job, man. What's my derivative, guys? My second derivative. Okay. And then dn is just 1, so I'm gonna skip that. Minus 90 minus 108. T plus 3 to the negative 4th. And then dn is just 1 again. Okay. I got tired of assigning this problem because no one could do it. It was the math, you see, it was the algebra. Because now we have to set this equal to 0 and solve for t. You guys ready? Yeah. So I'm gonna make this pretty again by bringing this stuff back downtown. So I'm gonna have 6 over t plus 3 quantity cubed minus 108 over t plus 3 quantity to the 4th. Is everyone okay with that? Okay. I'm gonna set it equal to 0. 6 over t plus 3 cubed minus 108 over t plus 3 to the 4th. I'm gonna bring this 108 over. So I'm just gonna add 108 over t plus 3 to the 4th to both sides. So I'm gonna end up with something that looks like this. And I'll give you guys a sec. I heard it, what was that? The values?
So when the 108 over t plus 3 to the 4, is just the 108 negative? Or is the whole thing negative?
It would be the whole thing, but that's like saying negative 3/4 is the same as 3/4 when it's negative. It's the same thing.
So you just move everything over each?
Yeah, I just added it to both sides. I just shifted it over. Okay? All right. So now what do I do, guys?
Multiply.
Yeah, I'm gonna multiply some stuffs. If I multiply both sides by t plus 3 to the 4th power, what happens over here? They cancel, okay? So we're gonna kill that. And what happens over here?
6 times t plus 3.
Yeah. So I got rid of this guy and all of that. You guys with me? Give me a shaky thumb if you're not quite with me on why the hell that happened.
Can you
Okay.
do it again, the multiplication of t plus 3, the black? What did you do?
What do you
I
mean,
understood
do it
this.
again? I'm trying to isolate the t plus 3s.
So it's like becomes a common denominator?
No? Excuse Thank you. And so satisfying. Okay, so all I did is I'm trying to get all my t plus 3s onto one side. Okay, so I'm gonna multiply both sides by this denominator so I can get rid of it. Okay? Now, for those of you that are confused about this, let me rewrite this in another way. What if I wrote t plus 3 to the 4th as t plus 3 cubed times t plus 3? Could I do that?
Yeah.
Yeah, so now what cancels? Just the t plus 3 cubes, right? So we're left with this guy. So does that make a little more sense? Those of you that had the shaky thumb?
So you subtract,
It's okay. That's what I'm here for. We got lots of time.
it just seems like you subtracted the exponents.
Yeah, I did, exactly. So think about it this way, guys. 3 to the 5th over 3 cubed is like saying 3 squared. And let me show you why that's true. 5 minus 3 is 2, but that's 3 times 3 times 3 times 3 times 3. That doesn't look like a 3. It looks like somebody had a party. Over 3 times 3 times 3, and I'm gonna kill those, leaving me 3 squared. Okay? You guys cool with that?
But if you
So-
brought it up, wouldn't that be a minus 3?
No, I'm not bringing it up. I'm multiplying both sides by the same thing. That's like having x equals 5, and I multiply both sides by 2. Nothing's changed. 2x equals 10, x is still 5, right? Think of equations as equal opportunity, guys. What you do to one side, you have to do to the other. Yes, and then yes.
So you multiply by t plus 3 to the 4.
Yep.
So would the t plus 3 that's left be negative?
Mm-mm. This is t plus 3 to the 4th.
Okay.
Let me show you why. Let's just say it's 3 cubed times 3.
Oh, never mind, I get it.
You see it?
I had it.
So that equals 3 to the 4th power. So whatever your base is, if it's the same and they're multiplied, you can add the exponents. Okay? All right. So are we good, guys?
No.
Emily?
How can you cancel the t plus 3 to the 4th and the t plus 3 to the 3rd if they have different exponents?
Okay, so I'm canceling two different things on each side.
Okay.
I'm canceling the thing that the denominator and the numerator have in common here, and I'm canceling the thing that the denominator and the numerator have in common here.
So
I'm
then
multiplying by the same thing on both sides. This is t plus 3 to the 4th power.
so then
okay.
you're left with just one t plus 3.
Yeah, so
So
let
it
me
would be
rewrite this, you
6
guys.
over t plus 3.
Yeah,
108, okay.
yeah, so here's what's left. 108 equals 6 times t plus 3. So I'm going to divide both sides by 6. And that's 18.
Pretty much.
18 equals t plus 3. 15 equals t. You did it the long way. What's the long way? Oh, yeah, you distributed it and then went through. Yeah. That works too. Algebraically, it's sound. Do you see why I don't assign this problem anymore? Because I'm tired of doing it 14 times in my office
Oh, stop.
and 5 times by text and twice at least on the board.
I said that text.
Yeah. Yeah. Copy paste.
Yeah.
How do you guys feel about this?
Is this gonna be in the exam?
Yes. Is it gonna be this hard? No.
Yes.
No, it's not gonna be this hard.
I didn't know how you got the 15T.
Do you know how I got here?
Yeah, 6 3s are 18.
Okay, so isolate your t. What do you do to both sides? Shh, let her do it. You see it? Okay. Sure.
No, I got it, because 18 minus 3 is 15.
There it is.
Thank you.
You're welcome. How do you guys feel about this?
Good. Do we want to do a production one for this chapter or no?
No, I want you to. I just gave you the hard one, I'm leaving you the easy one. Don't complain to me. Seriously, I'm leaving you one that doesn't have denominators, it's just a straight derivative, straight second derivative, set it equal to 0, solve for x. Don't overthink it, guys. Seriously. If you want to find the point of diminishing returns, that's your procedure. It's like finding a max or a min using the derivative. Take the derivative, set it equal to 0, solve for x. It's the same procedure, except now you're looking for a change in concavity instead of a change in slope. Get your pictures. I'm going to erase it in about 8 seconds.
1 second.
7, 5,
How's that?
3, 1. Seriously, not kidding.
Advance.
Okay. I hate chapter 10. I hate it with a passion.
You could just not teach us that.
I have to though because it's on your final. You know, the final I didn't write.
Is the final gonna be done by somebody else?
No, I run it and I grade it. And I write half of it, but I don't write the other half. The other half is written by the department and that part is all applications.
Why is that? Why can't
Because
you
the
write
department
whole
needs
thing?
us.
Because we're contracted to the business school to provide you information in a math context so that you can take that stuff with you in the business school. So they have certain benchmarks they want you to meet, and this is universal. And this is one of the benchmarks, so you have to know it. That's why. It's not us, guys. You wanna complain, take it to your college, because it's not us. We're just a contractor. All right, let's talk about optimization. Let's look at this scenario. This is a profit function, so this is gonna be dollars, and this is gonna be production in X. And let's say your function looks like this. Profit. Where's max profit? On the top? What's special about that spot? Slope is 0. There's another point where the slope is 0. So f prime equals 0. F prime equals 0. So we can just plug both of those x values, whatever this is, x1, that level of production, and here's x2, that level of production. We can just plug those into the profit function to figure out which one's higher, or we can plug them into the second derivative to figure out which one has a negative concavity, right? Either way will get us to the true max. You guys with me? Okay. So what if I told you, after we'd solved for those x values, let's say this is 600, and this is 1,200 units. But in the problem itself, you were given the following information. You cannot produce less than 0 items, duh, right? Can't go negative on the items. And you're limited to at most 1,000 items. And this could happen for several reasons. You could be limited by your employees' capability. You could be limited by the production space, like your manufacturing space. You could be limited by your sourcing of raw materials. Whatever the case, you're limited to 1,000 units. So where's your true max?
100?
600? Let's back this up just a second. It's not 600. So this was a false max, right? We found that. False max profit. This was the mathematical max profit, the one you found using math. But limited by the reality, reality being you can only make 1,000 of these, whatever the thing is that you're making. This becomes your realistic max. Because you can't go above 1,000. So if you find your mathematical maximum and you discover it's outside the bounds of what's given in the problem, you guys, these mean something in your problems. These right here, these terms, these limitations, they are important. They mean something. Did I say it was gonna be a short day? Damn. Well, I'd rather have you guys solid understanding than let you go early with less than solid foundational knowledge. So do you guys see how we would have to back off our profit from 1,200 to 1,000? So when you get a mathematical maximum, check the problem to see if you have limitations on your production. Groovy? That's all you have to do. You wanna see an example? Okay. You good? Get a picture? I'm gonna erase it.
Hold on,
Okay,
I was writing.
that's okay. Felt like fall this morning, you guys. I was so excited.
Cold.
I built like a polar bear. Got a lot of, shall we say, insulation. So I look forward to the cooler months. Makes me so happy. Yeah. Okay. Let me give you, ooh, let's see. Glad it's mine. All right.
So the inflection point was really where you could only get the maximum, that is your diminishing return. The 1,000 units.
It's not point of diminishing returns. That's a completely different
Oh,
concept.
okay.
Yeah, this is
optimization.
This is optimization, yeah. Absolutely. Okay. Let's see. Here we go. A small business has weekly average costs in dollars of, so this is weekly average costs. And in my textbook in the 11th edition, this is number 36 in 10.3. So small business has weekly average costs of this. 100 over X plus 30 plus X over 10, where X is the number of units produced each week. Okay. We also know the competitive market price for this company's product is $46. Okay. Production is limited to 150 units per week. Find the level of production that yields maximum profit. And find the corresponding max profit. Okay, so we're given a lot of information in this. Let's give you guys a couple minutes to write it all down. Stare at it. Okay. Now I'm going to underline the things I need. So I need a plan. I need to know what to do with all of this stuff. So level of production is another way of saying X that yields max profit. I'm looking for X that gives max profit, right? Where the hell is that located? How many of you did this with me on your test? Where's max profit, guys?
Right in the middle.
Up there. What's special about that spot?
0.
What's 0?
Slope.
Slope. And when you set the derivative equal to 0 and solve for X, this is the X that yields max profit. If you only have one, if you have two, you have to verify which one's the true max. So far, so good? Okay. So I'm also asked to find max profit. So that's profit at X max profit. That makes sense. So we take that X value and we shove it back into the profit function, and what do we get out? The real max profit, or the mathematical max profit, which we then have to check against what? Production is limited to 150 units. So that's like saying 0 is less than or equal to X is less than or equal to 150. You guys with me? That's our limiter. So we need to verify whatever X we get is between 0 and 150. And if it's not, we need to back up to 150. If you get a negative answer, we're in trouble. Can't have negative production, guys. Groovy? Does it make sense so far? Well, now let's build a roadmap. I need a profit function, don't I? That's where we're headed. So what is profit?
Cost minus revenue.
No, not cost minus revenue.
Revenue minus cost.
Revenue minus cost. Let me show you why it's that way. If you have $1,000 coming in and $500 going out, and you do 500 minus 1,000, what's the profit? It's negative. Does that make any sense if you have more money coming in than going out? No, always start with the money coming in, subtract the money going out, That's the way to do it. Does that make sense? Okay. Do I have a revenue function?
No.
No. Can I build one?
Yes.
Out of what? Revenue? I can build cost out of revenue or revenue out of cost? Those are two different animals, guys. Yeah, I heard it. Christina, price times quantity. Do I have a price?
$46.
So what's my revenue function?
46x.
Good. Do I have a cost function?
Yes.
No. I have an average cost function. Do you guys remember the difference between those? Maria?
You don't have the X underneath the cost.
Right. This average cost is cost per unit. That's what this is, guys. So how do I get cost out of this little equation here?
Get rid of the X,
By doing what to both sides?
setting it equal to 0.
Not setting it equal to 0, I heard it.
Denominator,
We multiply by x on both sides. Giving you the average cost times x gives you total cost. So we're gonna multiply this by x, guys. You guys with me?
This is a little bit off topic, but multiply by x means like we're gonna be doing an integral, right?
No, you're not doing an integral. Multiplying by x is not the same as integrating. Because when you're integrating, you have to resolve the denominator and the exponent at the same time. So the integral of x is x squared over 2 plus k. That's not the same as x squared. Does that make sense? Okay. We'll get there. Oh, yes, we will. We'll get there. So what's my cost function, guys? X times 100 over x is 100. X times 30 is 30x. X times x over 10 is x squared over 10. That's my cost function. That's C of x. Notice I'm labeling everything, because now I have a crap ton of functions. I have a price, I have an average cost, I have a total cost, I have a revenue, and I'm about to have a profit and a marginal profit too. So we're working with multiple functions here, guys. Label everything. I cannot stress this enough. Label everything. How many of you guys just do the math and forget the left-hand side? No shame. Don't do that. You're gonna be very sad when you do, because you won't remember what's what and where to shove what when. Which is bad. Okay, so let's build that profit function. Profit equals revenue minus cost. Profit equals 46x minus 100 minus 30x minus x squared over 10.
Can I ask you a question?
Yeah.
So when you said weekly average cost is cost over, the sign over it,
Mhm.
and you put X, all that junk, and then you got X out there,
Mhm.
shouldn't there be an X on the other side where the average cost is? With a C over X?
But remember what I did with that. Average cost is this. So this is where we're working. This
Yeah.
is our roadmap. So if I multiply both sides by x, I'm literally taking our average cost function, this thing, and I'm multiplying it by x here.
Oh, so you,
So I'm just doing what I decided I needed to do.
Okay.
So this is the math behind the roadmap.
oh,
Okay? So now I'm gonna collect like terms. What's 46x minus 30x? Yeah, 16x minus 100 minus x squared over 10. What do I do with that? So once again, I go back to here and say, where the hell was I? I'm lost. Yes?
How come that 30 would
Why did any of these go negative? When you subtract cost, you're subtracting the whole cost function, not just the first term. So every sign in your cost function is gonna change. This is gonna go negative, this is gonna go negative, this is gonna go negative. Does that make sense? So no matter what the sign was, it's gonna change. Groovy? Okay. So remind me, what were we supposed to be doing here? Find the X that yields max profit. So what was the roadmap over here that got me there? I do what?
Slope equals 0.
Yeah, I take the derivative, set it equal to 0, and solve for X. So that's what we do, guys. Here we go. Marginal profit equals 16 minus 2X over 10. 0 equals 16 minus 2X over 10. 2X over 10 equals 16. 2X equals 160. X equals 80. So I'm saying this is 80, right here. Double check it against my limitator. My limiter? Is that in the range? Yeah, so we're good to go, right? If we'd gotten a different answer, we'd have to check it again. So far, so groovy, guys? I have an answer.
Why did the 30 become minus 30? Because it originally was plus 30.
Okay, so again, when I subtract cost, revenue minus cost, I'm gonna subtract the whole thing. So I have my revenue minus my whole cost. So if I did minus my whole cost, these would have been plus to start with, right? You with me? So if I distribute that negative, everything's gonna go negative. Okay. Am I done? What do I do next?
The max profit.
I need max profit, so what do I do?
Plug it in.
Yeah, I shove 80 into what? Revenue? Price? Marginal profit?
Profit.
Cost? Am I looking for cost?
Cost average?
What was I asked to find? So where do I shove X to get profit? Profit. Good. So profit at 80 is 16 times 80 minus 100. This is why it's so flickin' important, you guys, to label everything you did. Because we have a crap ton of functions up here. I need to know which one I'm using. Yeah? Yeah. Sorry, I'm like yelling at you guys. I'm not yelling at you guys, I swear. Who's got the number? Yes, Christina. Yes. It's like Pavlov's dogs. I say, who's got the number? And you reach for your phone automatically. I must plug it in. I'm sorry, is that what you meant? I'm sorry. It's a good thing though. Did you get it?
I did it naturally, 540.
540?
I got 540 also.
540? Awesome. It's Anthony, right?
Yeah.
Yes. That's not bad for a weekly profit on a small business, right? Yeah. Because remember, profit is money after you've paid yourself, your employees, all your debts, everything. So you paid yourself, plus you get $540 a week in your pocket. That's not bad. Not bad at all. How do you guys feel about this problem?
Stressed.
There is nothing in here, Emily, that you don't know how to do. Nothing.
There's too many steps.
There are a lot of steps, but it's all logical, right? Start with what you're asked to find and craft all the things you need to find that thing, okay? Those roadmaps really help. Was that a question?
On that C over X,
Yeah,
do we always have to multiply by X?
yeah. Well, if you're asked to find something to do with cost, yes. If you're asked to find something to do with average cost, no, because you're set. You have an average cost function, right? So it's RTFQ, okay? This average cost and total cost stuff is covered in the basics of business in the context of this class. It's also covered in the handouts I'm about to give you.
What is RTFQ?
Read the full question. Read it fully, read it thoroughly, read it completely, read it twice.
That is the formula that I use.
Yeah, no, it's
Early
okay.
morning.
RTFQ.
Yeah.
Welcome.